today is really just to compare numbers. So the first comparison we're going to do is to take a number and turn it into a decimal. So we want to take a number and turn it into a decimal. So you're going to use the calculators to convert numbers that aren't easy into decimals. So if you need a calculator, raise your hand. We'll bring you one. If you have a calculator, that's great. If you use your phone, that's fine too. So number 1, 4 divided by 5. So what you're going to do is take the number 4 divided by 5, because a fraction is really just a representation of division. So how many times does 4 go into 5? It goes in 0.8. Is this a terminating? Do I not give him one? Is this a terminating or repeating decimal? Good, what do you think? It is terminating because you typed it in and your answer was done. Okay, 4 divided by 11. So when you do 4 divided by 11, you get 0.36, 36, 36, 36, 36, 36, etc., etc. So when that number repeats itself, we really only want to write up to where it starts to repeat. So instead of writing 0.3636363636, which goes on and on and on forever, we're going to write 0.36, and we're going to draw a bar across the top. That indicates that this is a repeating decimal. And it tells me that it goes 0.36363636363636 forever and ever and ever and ever. Okay? Nevaeh, what's 5 divided by 8? Perfect. Luke, what's 7 divided by 9? Yeah, so that's what type of decimal, Luke? Perfect. So 7/9 is 0.7 repeating. So we draw our bar on top of a singular 0.7. And we say that that's a repeating decimal, which meant that letter C, and I forgot to ask, was terminating. Logan, what's 5 divided by 12? Okay, so how he said his calculator rounded that 6 to the 7, our calculators cannot indicate a repeating number using the bar like we do. So that's why fractions are so important, because when you plug in a fraction that's a repeating decimal, you're going to get a different answer than if you plug in the decimal version of the fraction. So this is actually a repeating decimal. And when you put the repeating bar, you only put it over the 6. So the repeating bar does not go on the 4 or the 1. It would be 0.416 repeating. Okay? And Zoe, 3/4. Perfect. And Abby, is that terminating or repeating? Excellent. Questions at all on decimals? Okay, so the second part of what we're going to look at is ordering numbers. We order numbers by transforming fractions to decimals, percentages to decimals. So in order to divide or convert a percent to a decimal, we have to divide by 100. For now, it's important to have at least 2 decimal places. And then what we're going to do is we're going to compare those decimals. So to compare means to look at which one is larger, or order them from least to greatest. So to determine the correct symbol, we first convert fractions and percentages to decimals. So the very last example we looked at for a fraction was 3/4. We said that that was 0.75. We now want to compare 3/4 to a 96.6%. So what we do is take 96.6% and divide it by 100. So again, you don't have the numbers, you just have the blanks. You're filling in those numbers. So 3/4 compared to 96.6, using greater than, less than, or equal to. 3/4 is less than 96.6%. And our first example, second page. You get the words from the previous slide on the front page. And you need to go back to give you the words on the previous slide. Yes? Okay, if you did not fill in the blanks on the previous slide, go back to the first page. All right, so let's compare the values of real numbers by inserting an ordering symbol that makes the statement true. So we have 5. Is 5 greater than, less than, or equal to -12? Good, Zoe? Yes, it's greater than. So that's where you insert your little like alligator Pac-Man symbol, whatever you want to call it. And we say that it is greater than -12. Letter B. Is 9 less than, greater than, or equal to 17? Nevaeh. Perfect. Okay. -4.8. Is it less than, equal to, or greater than -4.7? All right, Zoe, what do you think? Perfect. So negatives are backwards to their positive, right? A larger negative number is smaller than a smaller negative number. Okay? Letter D. 1/2 and 8/16. Greater than, less than, or equal to? Nevaeh. All right, so what's the rule or the directions when you're comparing real numbers? If you have fractions, what are we supposed to do to them? Turn them to, yes. So we want to turn 1/2 and 8/16 into a decimal so we can compare them. So Luke, what is 1/2 as a decimal? Excellent. And what is 8/16 as a decimal, Sierra? Remember, you got a calculator, you can do it. Logan, what'd you get, honey? That's what I got too. So everybody, are we okay with that now? Okay, the last thing we have to talk about is absolute value. Absolute value is the distance between a number and 0 on the number line. It is the distance between a number and 0 on a number line. Okay? So what is the absolute value of 11? How far away is 11 from 0? 11. The absolute value of -14.2. So it's just to the left, -14.2. So it's 14.2 units from 0 on the number line. How far away is 0 from 0 on the number line? What do we think? Zoe? Yeah. The absolute value of 0 is 0. Absolute value bars act like parentheses. So before you take the absolute value of 9 plus 4, you have to add 9 plus 4. So you get the absolute value of 13, which is 13. That means in letter E, before we take the absolute value, I have to add negative 9 and 4. Before I take the absolute value, I have to add negative 9 and 4. So what is negative 9 plus 4? Zoe? Exactly. So it's the absolute value of negative 5, which is 5. Your homework is the next page.